Today in this flipped classroom video, we're going to be going over the amount of energy that it takes to change a substance from solid to liquid to gas. Now, you guys have already done this in some ways. You've calculated the amount of energy that it takes to change an object from one phase to another. That is the energy required here for our phase change. So when you calculate the amount of energy required for phase change, you're using this equation, and that's the one that should look familiar. This is when you have the heat, which is represented by Q, and that's equal to the mass of your substance times the heat. Now this heat, the H here, this is a constant, and this could be like the heat of vaporization, the heat of fusion. This is really the heat of whatever you are figuring out or whatever change you're going from. So if you're going from liquid to gas, you would be looking here at the heat of vaporization. All right? Now, if you were going, let's say, from solid to liquid, it would be a different heat. If you're going from liquid to solid, you would have the heat of fusion because you're fusing back together. All right? Now, luckily, these values are always constant. So in a given problem, they would be given to you. All you would have to do would be to plug in this mass value here. Now, that would be the heat that you have to put in to turn an object to go from the start of a phase change to the end of a phase change. Now, in some cases, you're not really looking for the heat required to go from the start to the finish of a phase change. Instead, you'd be looking for the heat required simply to raise or lower the temperature of a substance. In those cases, really what you're looking at is the heat required to go whenever you're raising your temperature. So for example, from my liquid here at this temperature to my liquid here at this temperature. So in that case, you're going to use a totally different equation. And this equation is just for when you have a temperature change. In this equation, you still have Q, that's still representing your overall energy that you're putting in. But now you have M for your mass times C times delta T. MC delta T. So in this case, M is your mass. C is a different constant called specific heat. Again, you would get that for whatever substance you were looking at. And delta T is simply the change in temperature. So if you're starting at 50 degrees and you're going to 100 degrees, your change in temperature would just be 50. So now that we've gone over what these two equations are, I'm going to do a quick video on how to actually use these equations. Alright, so here's our practice problem. This practice problem is the one that is written on the board. So this would be how much heat is required to raise the temperature of 100 grams of water from 20 degrees Celsius to 80 degrees Celsius. So we're going to set this problem up in a very specific way. We're going to have 3 different columns. The first column is for our given information, things that we got from the problem. The second column is going to be for the equation that we're using, and the third column is going to be for solving. So in this case, our given information is what I've listed. We know that the change in temperature is going to be from 20 to 80 degrees Celsius. We also know that the mass of water is 100 grams. And finally, we know that we're dealing with water. One thing that I did is I looked up the quantity or the amount that C is going to be in this case. Like I said, C is a constant, so that's something that we can find online. So I looked it up, and in this case, C, our constant, is 4.179, and its units are joules per gram and degree change. So in this case, what we're looking at is using our equation, Q equals M times C times our change in temperature. So here we have Q, if we're plugging it all in, Q is equal to our 100 grams, that was our constant, or our amount from the problem, times our constant value, times our change in temperature, which in this case is 60. So what you can do is plug that all into your calculator and solve for it. And that's the thing that you should email me to get the extra credit points for this class. Email me the solution to this problem.